Welcome back, Algebra 2 students. It's good to see you. In this video, we're going to look at transformations of absolute value functions. We're going to take this graph that we looked at in the previous video for absolute value of x, and now we're going to put some numbers into this equation. Well, we're going to find out that depending on where we put these numbers in and whether they're added or subtracted on the inside of the absolute value bars, that's going to move the graph one direction. If we add or subtract on the outside, it's going to move the graph in a different way. If we multiply the function by a certain number, it's going to change the graph in another way. The good news is, once you learn these transformation rules, every function that we study all year from now till May, every function has the exact same transformation rules. Right? Let me tell you a little bit what I'm talking about. We're going to go to a different background. So here is our parent function. We're going to write it in this general form. And what we're going to learn, what we're going to see through some investigation here is that this k, notice this k is added and it can also be subtracted on the outside of the absolute value bars. We're going to see that that has a certain effect on the graph. We're going to also learn what happens with this h. Notice, where is the h? The h is inside the absolute value bars. That h is going to have a different effect on the graph than the k does. There's also this a. And this a has yet another effect on the graph. So let's go back to our Desmos. And let's see what happens when we put a k in there. So let's have f of x. Remember, the k was added or subtracted on the outside, right? Let's do f of x equals absolute value. Remember, it's down here in the keyboard. X. Now we want this outside, so I'm going to hit the right arrow key to take me outside the absolute value bars, and I'm going to add a plus 2, not an equals. How about a plus 2? Enter. So we see what happened to that graph. We added a number outside the absolute value bars. Let's try that again. Let's add a different number. F of x equals absolute value x, right arrow, plus 5. That's green. Do you see it? Oh, it went away. Actually added some more numbers. I didn't mean to. There it is. So what happens to the graph when you add a number outside the absolute value bars? Okay. If you said it moves up, you are correct. That's called a vertical translation. Okay, a vertical translation. It shifts the graph up. Okay, let's see. What else can we do? What if we subtract k? Right arrow to get outside the absolute value bars, minus 4. Uh-oh, you know why I'm not seeing anything? I missed the equal sign right here. There we go. What happened to that graph? Let's look again. F of x equals, uh-oh. Mine likes to jump tabs sometimes, just for the heck of it. Absolute value, I'm in the wrong spot. There we go. Absolute value of x minus 1. Okay, compare that one. It's kind of a dark blue or a black there. Compare this one to the red one. What happened? When we subtracted 1, it moved down. How many? 1. That's another neat thing with Desmos. If you hover over that point or click on that point, it will tell you what that point is. Look, here's absolute value of x. Here's absolute value of x plus 2. Absolute value of x plus 4. No, that's 5, sorry. And then we did a -1 and a -4. Okay, so stop here and tell me what happens if you add a number outside the absolute value. And then tell me what happens if you subtract a number outside the absolute value. Okay. Now let's take these off. There, we're back to our basic parent function. No transformation has taken place. Now, what happens if we do some adding or subtracting inside? What do you think is going to happen? We saw that if you add a number outside, the graph moves up. If you subtract a number outside the absolute value bars, the graph moves down. What do you think would happen if we add a number inside the absolute value bars? Let's see if you're right. Now, I'm using fairly small numbers, so it's on the graph. You can make these numbers as big as you want. It would zoom around. It might look a little crazy. And you can also, when you're using decimals, you can change this color. I just held that down because I don't want it to be red like the other one. I want that one to be blue. You can turn that graph off and on. If I hit that, that graph's turned off. Notice you don't see it. Hit it again. It's turned blue. Hold this down, click and hold, and you can change the color. You can change, oh, I didn't know you could do that. That is awesome. Okay. So, besides our little Desmos tutorial there, what happened to the graph? What happened to this parent function that's red when we subtracted 4 inside the absolute value bars? Is that what you expected? Now let's try another one. F of x equals absolute value x minus, which way did it go? Is that what you expected with x minus 7? Right. It moved to the right. Sometimes when we see that -7, we're going to think to the left because it's inside those absolute value bars. It's awesome because it's opposite because you're actually subtracting from the x and then taking the absolute value. Okay. So now that we see that if you subtract inside the absolute value, it moves to the right, what do you think is going to happen if we subtract? Nope. If we add a number inside, what do you think is going to happen? Where is it going to move? Move to the left. So inside the absolute value bars, that transformation is going to appear to be opposite than what you think. Plus moves to the left, minus moves to the right. Okay? Inside the absolute value bars. And later with our other functions, it'll be inside parentheses or inside the square root or inside the exponent or inside the logarithm or inside the cube root. Any addition inside the absolute value, addition moves it left, subtraction moves it right. If it's inside the grouping symbol. Let's see another one, just so you believe me. Absolute value of x plus 6. Okay. So what have we learned? We've learned that an add or subtract outside the absolute value moves the graph up or down. And it's like we think it should be. Plus goes up, minus goes down. When you add or subtract inside the absolute value, it's opposite. The minus goes to the right, the plus goes to the left. Now, is it possible to do more than one transformation at the same time? F of x equals absolute value x minus 3. Use your right arrow to get outside the absolute value, plus 2. What happened to that one? Which way did it move? What was the transformation that took place? This transformation went to the right 3 and up 2. Okay, to the right 3 and up 2. Let's try another one. F of x equals, if you were in the class, I would let you be calling out the numbers. Absolute value, x plus 4 minus 3. It zoomed a little bit more than I wanted it to, but notice, what are we looking at? When I say moves up or down, moves left or right, what am I talking about? I'm talking about this vertex, this turning point, moves from 0, 0 in the parent function. So this one moved right 1, 2, 3, up 2, right? And this one moved left 4 and down 3. When we finish this transformation lesson, and as we study transformations more throughout the year, you won't even need to graph. You'll be able to look at this equation and tell me this is the absolute value function translated 3 units right, 2 units up. Because we will have talked so much about what does the A do, what does the H do, what does the K do, which way does it move. You'll be able to look at the equation and you could draw that graph without even typing the calculator, without even counting any points or looking at a table, because if you know your transformation rules, then you know which way that graph has moved. Okay. What would happen, do you think, if we put a negative in front? Negative. Lost my keyboard. There it is. For some reason, I've zoomed in or out. It's not working like I wanted to. All right, we're going to do this. Need some Jeopardy music while we just switch over. So what we were talking about, we've learned that the K, or a number added or subtracted outside, moves the graph up. A number added or subtracted inside moves the graph left and right, and it appears to be backwards. If we have a negative in front of this absolute value, do you remember what the parent function looked like? Absolute value of x looks like a v. What does negative absolute value of x look like? And it did not show up. Why did it not show up? There it is. Zoom this back to where it was. Okay, there's our, sorry for making you dizzy. There it is, absolute value of negative x, or negative absolute value of x, reflects that graph across the x-axis. What's that mean in plain English? Flip it upside down. So instead of a V that opens up, we've got a V that opens down. The vertex is still at 0, 0, so that didn't move, right? It hasn't moved left. It hasn't moved to the right. It's only reflected across the x-axis, and I don't know why it keeps doing that. Okay, reflected across the x-axis. So then, can we put in our other transformations? F of x equals negative absolute value. Let's do x minus 3 plus 4. Okay, do you see this window has gotten way wonky here? Look, we've got 20 and 50 and, okay. Nope, no one did that. Okay, I know an easy way to fix this. Go right here to this little wrench in the corner. And I want this x-axis to be from -10 to +10. And I want the y-axis to be from, it's like adjusting the window on your Inspire. It's going the wrong way. Here we go. Okay, so look at this. Here's the negative on the outside, right? The negative on the outside of any function reflects it across the x-axis, or basically flips it upside down. It takes all the points in the parent function. Here's our parent function. And it just flips it upside down. So look, we can turn this one off and this one off. Okay. Here's the purple. This is our original absolute value parent function, y equals absolute value of x. Shaped like a V, vertex at the origin, opens up. When we throw a negative in front of that, this red one, it has reflected every point on the original function across the x-axis. So this point goes here. This point goes here. It's reflecting over the x-axis. Flips it upside down. Takes that V, flips it upside down. Whoa, knocks my headphones off. Takes a V, reflects it. A negative in front. It does that for a parabola, does that for a square root, does that for every function. A negative in front reflects across the x-axis or flips it upside down. Okay? Now, if we can also do these other transformations. So this one, I'm going to turn it back on, is negative absolute value of x plus 2. The plus 2 is on the outside, so that moves it 2 up. We do not want a Google Hangout. Here we go. Turn that on. There's the flip. Notice it's upside down, but the vertex instead of 0, 0 has been moved up to 2. This one has a negative. It's going to flip it. 3 to the right, down 2. Am I right? Boom. Here it's green. Flip it. Right 3, down 2. We're looking at that vertex to see where it moved. Okay, so what have we looked at so far? We've looked at the addition or subtraction on the outside That's the K. Moves it up or down. Addition and subtraction on the inside, that's the H. Moves it left and right. A negative on the outside, that's the A. If it's negative, it's going to flip it or reflect it across the x-axis and make it go, it turns upside down. The mathematical terminology for that is reflect across the x-axis. Now, what if we put, here's the parent function. This is our foundation. This is where we're starting. I don't want that right there. I want that right there. Okay, that's our parent function. Absolute value. It's a V, has the axis of symmetry on the x equals 0, has the vertex at 0, 0, opens up. What if I add a number in front? What about that A? Remember we had A times x minus h plus k. See if I can still write on here. Yeah. So you remember we had y equals, or f of x equals A times absolute value x minus h plus k. We've already seen that a plus k makes it go up. A minus k makes that graph go down. We talked about the h, the number that's inside the absolute value. A plus h goes left, and a minus h goes right. We talked about, and if this number is negative, a negative a is a flip or an x-axis reflection. But what if that a is a number? Can that a be a number? What if we had, okay, I got to make that go away. Just go away. So let's put a 2 out there in front of it. And 2 times the absolute value of x. I didn't type the f of x, but it should take care of it anyway. Okay, so when we made the a 2. That's the red graph. What happened to it? Let's try another one. What about if we did 4 times the absolute value of x? That's blue, the light blue. What if I did, I know you guys don't like fractions, but what if I did 1/2? I just typed 1/2 and Desmos converts it to that fraction. Easy. Now I don't want that in the bottom, so I'm going to use the arrow key to get out of the fraction. And then put the absolute value. Okay, the 1/2 absolute value of x is green. Okay. What happened? No Google Hangout, thank you. What about 1/4? We can make a really pretty picture. Watch this. What's happening to this? Okay. I got a little carried away there, making a picture. There is, do you see how when you're working with this, you can turn these graphs off? I didn't take out the equation, so just turn the graph off. There's a parent function, absolute value of x. What happens if I change the a to a 2? That graph got narrower or skinnier. That is called a vertical stretch. Think about a rubber band. If you take a rubber band and you stretch it vertically, verticals up and down, If I stretch a rubber band vertically, it gets narrow or skinny, right? So this number, this 2 seemed to make this graph taller or narrow, not really taller, skinnier, right? It's called a vertical stretch. Vertical stretch, okay? What did the 4 do? Vertical stretch. If it got narrow or it got skinny, that's vertical stretch. What about 1/2? Oh, that didn't get narrow, did it? That one got wider. That's called a vertical compression. Think about that rubber band. If you squash it like this, verticals up and down, vertical compression makes it flat or wide. You can remember that by fractions make it flat, okay? Fractions and flat, F and F. Fractions make it flat. That whole number, that 2 or that 4, something bigger than 1, is a vertical stretch. Vertical stretch, a number bigger than 1. If A is bigger than 1, vertical stretch makes it skinny. If A is between 0 and 1, it makes it wider. That's your vertical compression. And if the A is negative, look, this is negative and wide. 1/8 is negative and wide. -2 is negative and narrow. Okay, that's a lot of transformations there, but what does this all mean? Okay, so here's our form of our equation. Okay. If A is greater than 1, that's called a vertical stretch. Think about a rubber band. If you stretch it, it gets skinny. Okay, then you have the A between 0 and 1. What kind of numbers are between 0 and 1? Fraction. Fraction is between 0 and 1. That makes it skinny. That's called a vertical compression. Makes it wide or makes it flat. That fraction makes it flat. If the A is negative, A is less than 0 means A is negative, then that's an x-axis reflection. Now the number there will still control the width. Okay, the number will still control the width. If you have a negative and a 2 that's bigger than 1, it's going to flip and it's going to get narrow. If you have a negative 1/4, it's going to flip and it's going to get wide. Okay. All right. Let's see if we can tie this up a little bit. So our transformation rules. Here's our function. All right. A plus k moves the graph up. It's called a vertical shift. Vertical shift, or it moves it up. Vertical translation, you can say. Anything vertical means up and down. Minus k goes which way? Down. The h. If you have x minus h, that's going to the right. If you have x plus h, that's going to the left. Okay. Then we have the a. If your a is greater than 1, that's a vertical stretch. Think about a rubber band. It gets skinny. If the a is between 0 and 1, that's a vertical compression. If the a, that stretch is going to make it narrow or skinny, this compression is going to make it wide. If you have a less than 0, that's going to be an x-axis reflection. That's your negative, that flips it over. Okay, we can get really a little more complex and put this b in here. Okay. A b, actually I guess I need to do a different color because I already did it green. If you have a number in there So if you have y equals absolute value of 2x, if that b is greater than 1, that's going to be a horizontal bigger than 1 is going to make it skinny, so that's a horizontal compression. Okay, think about this. Vertical stretch makes it skinny, horizontal compression makes it skinny. If that b is between 0 and 1, that's horizontal stretch. What happens to something if you stretch it horizontally? It gets wide. Okay, horizontal stretch, horizontal compression. Vertical stretch, narrow. Vertical compression, wide. Okay, you'll see much more with the A, not so much with the B, but I need to show you both. Okay, a negative in front always flips it over. All right, that's transformations. See you soon.